I'll try to show you some result about 15 years of snow cover monitoring of Sardinia by MSG data. Can you see next slide? Next, yes. Sorry, the previous. The studio aim is the production of monthly or seasonal snow cover maps. The snow cover days in a month or a season. Okay, next. Let's see the base of the procedure. We use 3 channels of MCG. The 1.6 micron, the 0.6 visible, and the 12 micron thermal infrared. At 0.6 micron, the snow has a high reflectance, higher than free land or bare soil, but reflectance similar to ice cloud like this on the Mediterranean, or like similar to water cloud. On the contrary, at 1.6 micron, the snow, as you can see on the Alps, has a very low reflectance, and also the ice cloud have low reflectance, while the water cloud have high reflectance. So if we make the ratio between the 0.6 reflectance and the 1.6 reflectance, it is called the snow index. The snow pixel has higher than 1 snow index. Also, the ice cloud is higher than 1 snow index, while free soil has a snow index less than 1, and also the water cloud has a snow index less than 1. So the snow index cannot, by using the snow index, we cannot distinguish the snow by the ice cloud, but only by water cloud and by free land. To discriminate the snow by ice cloud, we use also the 12 micron channel. As you can see here, at this channel, the snow is warmer, much warmer than ice cloud. So if you use as reference the soil temperature, also the humidity temperature of an atmospheric model, we can discriminate by this reference the snow by the ice cloud also. Okay, please the next. Oh, sorry, sorry. It is very useful. The previous image. Yes, we can see on this red, green, blue composition the snow on the Alps, which is much different from the ice cloud. The snow is green, the ice cloud has a blue component, and also is different, very different from the free soil, which is about red. It is different from water cloud, red, orange, or yellow. Okay, please next. Yeah, the first step of the procedure are the production of the temporary daily maps. We can see the next. Also the next, please. Yes, this is the algorithm. The algorithm has been tested in the testing phase for different values of snow index threshold and compare to ground station data. 1.1 is the best value of snow index as a threshold. We also use it to meet the temperature of the model, of the ECMWF model, to discriminate between snow pixels and ice clouds. And we use also the threshold of 25% at 0.6 radians and 12 to discriminate between pixel snow-free and water clouds. The 12% threshold removes the lakes with high snow index. Oh, please, can you see the next slide? Okay, also the next slide again. The second step of the methodology is the daily maps correction for the cloud cover. In order to reduce the cloudy pixels, this second phase is performed on the daily maps. It analyzes 3 or 4 consecutive daily snow cover maps and follow this criteria. If the pixel on the first day is snowy, and on the second day it is cloudy, and on the third day is snowy, we assume that also on the second day the pixel is snowy. Similar, if we have 4 consecutive days where the first day the pixel is snowy and the fourth day the pixel is snowy, we assume that also on the second and on the third day the pixel is snowy. Why? If we have on the first day the pixel is snow-free, on the second day is cloudy, and on the second day the pixels is again free, we assume that also on the second day the pixels is free or, you know. Finally, if we have on the first day the pixels is free land or free soil, and on the second day the pixel is cloudy, and the third day the pixel is snowy, we assume that also on the second day the pixel is snowy, because these clouds have brought the snow precipitation. The verification by comparison with station data has shown that this hypothesis is correct. With this correction procedure, the cloudy pixels identified as snowy or snow-free are about 10% of total. Oh, can we see the next slide, please? Okay, this is the daily map after cloud correction for 4th January of 2021. We can see there is snow over the Gennargentum top, over Corso Mountain, over Etna Mountain. Also over Etna Mountain there is again some pixel, some cloudy pixels. There are some cloudy pixels also in the image. Oh, can we see the next slide, please? Can you see the next? Okay, the third step of the methodology is the production of monthly and seasonal maps with the calculation of number of snow-covered days in a month or in a season. Now, because there are again in the daily maps, there are again some cloudy pixels, we assume this hypothesis, that is the conditional clear sky relative frequencies of snow cover and the marginal frequencies of snow cover in a month are equal. We have verified this hypothesis, as I will show you in the verification, and the root mean square difference between the two frequencies are about 1%, 1.5%, while the main differences are about 0.1, 0.2%. Can we see the next slide? Oh, this is the monthly map that shows the number of snow cover days for January 2021. We can see over January to top between 25 and 31 days of snow cover, also on the Etna Mountain and on the Course Mountain between 25 and 31 days of snow cover.
2 minutes.
We can see that, sorry?
2 minutes.
2 minutes. Oh,
Yes.
thank you, Sharon. Can you see also the next slide? Oh, this graph presented the days of snow cover over January to top. From 2007 to the last winter, about 15 years of snow cover monitoring. We can see that the lower value are about 5 days on the winter 2019, 2020, the previous winter, while the higher values are about 70 days on the 2010, 2011 winter, and on the 2012, 2013 winter. The median of this series is about 40 days. Of course, there is a high interannual variability. Can we see the next? Yeah, the procedure has been verified by using 139 ground stations, and between January and May 2005, the daily ground measurement has been compared with the collocated pixel information of the snow cover map by making contingency tables on monthly basis. The following indices has been calculated: the probability of detection, the false alarm rate, the bias, the threat score, the hit rate, the fraction of mixing, the fraction of fails. The verification has been made both on the temporary daily maps and on the daily map corrected for the cloud cover in order to evaluate the efficiency of the cloud cover correction procedure. Can we see also the next? So it is on the right. There is the daily map, the verification with cloud correction. On the left, the whiteout cloud correction. The indices on the right and the left are equal. That means that the cloud correction procedures maintain the same performance of the procedure, but it gives us 10% more information. By the hit rate is about 95%. Missing are about 5%. The fails about 2-5%. Can you see the next slide, please? Yeah. We can see here that in April and May, the procedure performance are bad, are not very good. We think it is because in April and May there are too many partly snowy pixels. many bounties knowing pixels. And the bias is between 80% and 95%. That means that is a very little underestimation of snow pixels. And yes, the last.
Can you conclude? Can you conclude, please?
Yes, yes. This is the multi-frequencies. This is the multi-frequency verification. Rutimesque about 70%. I want the main difference 1.5%. It is this underestimation. Okay, I have the last. I have finished. Chair, I have finished. The last.
Okay.
Of the next. Okay. This is I spoke about this root-mean-square differences for the conditional sky frequency and marginal frequency. I thank you for your attention.